Okay, problem 7.15. Suppose h is twice differentiable. Okay, that means that h prime and the second derivative, h second, exists. Okay, and let f of x be defined piecewise and to be h of x divided by x squared when x is different than 0 and 1 when x is 0. Right. So, and the question is to calculate h at 0, h prime at 0, and h second at 0 so that f is continuous. Okay. So in order for f to be continuous, okay, we suppose if h is twice differentiable, then that means it's continuous, right? So this is h divided by a continuous function. F is continuous whenever h is different than 0, right? So the only problem is when x is 0, right? Because then f, the limit when x goes to 0 of f has to be 1, right? That's the property of, or the definition of continuity, right? Well, that means that the limit when the limit when x goes to 0 of h divided by x is going to be 1, right? But this is going to go to 0, right? So if the limit when x goes to 0 of h of x, which is h at 0, right? Because h is continuous. If this limit is different than 0, right, then this is something divided by 0, which is either plus or minus infinity. It cannot be 1. Okay, so we have that h at 0 has to be 0 in order for this limit to be 0 divided by 0, right, and not infinity. So now we need to apply L'Hopital's rule and say, well, in order to solve this indetermination, we need to differentiate both the numerator and the denominator. And then we have the same thing again, right? If you want f to be continuous, this limit has to be 1. But again, the limit when x goes to 0 of h prime, which is h prime at 0, because again, the derivative is continuous because it's differentiable, it has to be 0, because otherwise this limit would be infinity, plus or minus infinity, right? So if this is 0, right, then we have 0 divided by 0, and applying L'Hopital's rule again, we have h second divided by 2 has to be equal to 1. Okay, so this implies that the limit when x goes to 0 of h second, and we are supposing that this is the same as h second at 0, is going to be 2, right? And that solves the problem.